Excuse me. Yes. Hi there. My name is Stars. What's your name? Oh, okay, good. I found you. Yeah, I'm the senior organic chemistry tutor, and you're the one who applied for some tutoring sessions? That is you. Okay. Well, it's very nice to meet you. I'm your new chemistry tutor. Yeah. Well, I think we're going to get along great. That is, if you like really, really bad chemistry puns. Huh? Oh, well, you could say I'm aiming to aid your education. Yeah, that bad. Especially since you'll be having exams at the end of this semester. Okay, that's it for now, I promise. I promise. Okay. See, you're laughing already. That's a good sign. All right. Why don't we go and sit down somewhere and we can make a start? All right? Okay. Ugh. Right, okay. So firstly, how are you finding your chemistry classes currently? Yeah, yeah, that's good. That's good. Who do you have as your professor? Oh, Dr. Mayer. Okay. Yeah, I remember him from last year. Or not last year. Well, I had him last year, but yeah, for when I was in your year. Yeah, his exam was a little tough, but you should be fine. Do you remember what was covered last week, just so I know where to kind of think back to? Uh-huh. Oh, ionization. Right, okay. So have you covered alkylations? Yes. Okay. Have you covered the Aldol reaction? Yes. Okay. And have you covered? Is that's as far as it goes? Okay. Um, yeah. All right. So let me just grab some paper. Right. Okay. So can you remember how they are formed? As in, sorry, enolates or enols. Can you remember how they're formed? Yeah. So we have any kind of like carbonyl like this, and obviously there's a proton that's like one carbon away. You use, what's this called? Yep, you use a base, it attacks here, forms a bond, goes up there, just like that. Yep, yeah. So do we know why this is special? As in why it's good to form an enolate? Exactly, right. So this can be used to form a carbon-carbon bond, which is really important when, if you're designing like a drug or something, this is a really reliable way to form a carbon-carbon bond and make your target molecule bigger. Right, okay, so you said you covered alkylation, so we can briefly just go over that. So if I have something like this, and then, for example, a haloalkane, we'll just use the bromine one like that. Obviously, we can deprotonate like just like that. It forms the enolate, going down that way. And this is nucleophilic. It's going to attack here. Yep, it's going to attack that carbon, go down there, expel the halides, and we've just reformed the ketone, but then this goes down here, and we've got 1, 2, 3, so 1, 2, 3. There you go, carbon-carbon bond formed. Right. Yeah, you learn a lot more about enols as take more classes. It does get really interesting, but also really complicated. There's like multi-step reactions, and yeah, but it's manageable. Um, I say. So yeah, so that's alkylation. You said you know about the Aldol reaction, don't you? Yeah, okay. So just really quickly again, if you have something like this, you're going to form, can you draw the product? If you have this ketone here and then this aldehyde, do you know what you're going to form? Yeah? All right. Yeah, that looks about right. So 1, 2, 3, that's going to go down there, and then you've attacked the carbonyl center to form an alcohol. Yeah. Yeah. So it's 2 carbons away. So there's a special name you give the product of an aldol reaction. It is called I don't know if you were taught this. It's called a beta hydroxy ketone. That's the fancy name, because this is the carbonyl carbon, that's the alpha carbon because it's 1 away. This would be the beta because it's 2 away. So beta hydroxy ketone. This is like a constant. An aldol reaction always forms a beta hydroxy ketone. Yeah. Sorry, say that again? Yeah, okay. Do we know what can happen here? Let's say like there's a huge amount of base in here. There's a proton there. Do you know what's going to happen? Yep, so this goes down here, form a double bond there, and then we expel the hydroxide. So now we have this. Do you know what you call this? Okay, so this is called a alpha beta unsaturated carbonyl compound, or just carbonyl. There you go. And this is, so if you do the Aldol reaction, and then because this is the dehydration, right? You're removing a water molecule. This is called Aldol condensation. Because condensation, you're removing water. I'm sure you remember that. Yeah, and aldol condensation always forms an alpha beta unsaturated carbonyl. Yes, exactly. It's alpha beta unsaturated because the double bond is between the alpha and beta. Yeah, and also note how it's conjugated now. Yeah, so you can do that, and that's a resonance form. So do you remember this? Like that, and then you got a positive charge there. This is the resonance form. That's why this is more stable. Okay, so have you learnt about the conjugated addition? Okay. I'm trying to think what else we've learnt about. Oh, yeah. You can ask a question. Anything. Yeah, you can stop me anytime and ask anything, you know. Yeah, so can you see, if I just move a little bit closer, oh my God. Oh yeah, no, it's nothing. It's just, right, okay. Oh my God. Okay. Right, no, it's nothing. So can you see here? Yeah, so with this compound, it's nothing, don't worry about it. All right. Okay, this might be a little bit too forward, but you have a really strong and very pleasant scent. I don't know. It's a very nice perfume you have on. That's all. Just when I move closer, I could smell it. That's all. Anyway, I mean, yeah, it smells nice. I'm trying. I'm okay. Um, oh my God. Okay. What What perfume is that? Oh, it's a strawberry one. Okay. Well, okay. With that in mind, I'm just going to, if you just pass me the pen. Yeah. Okay. So I don't know if you know this, but you've studied esters and esterification before, haven't you? Yeah. So there is this molecule. I'm trying to think what it looks like. Trying to think what it looks like. I know it looks like that, and then you've got this group attached. Okay, so this molecule, this has a really weird name. It's called ethyl methyl phenyl glycidate, I think it's called, but it's just known as something called strawberry aldehyde. Yes, this is the chemical responsible for the smell and the taste of strawberry. Did you know that? Well, there you go. Actually, yeah, you can see here, this has an ester group. So, and it has a hydrogen there. So this can be enolized as well. So you do that, that would go there, and that would go there. And then you'd form this enolate here. It's a bigger molecule, so it'll take a little longer to draw. There we go, like that. And okay, so let's say we have strawberry aldehyde in solution. We enolize it using a base. And let's just have this ketone here. Actually, yes, let's have this ketone here. So, okay, here's the pen again. So I would like you to draw the product of the aldol condensation reaction. Yeah, okay, so obviously we're going to start with what? Yep, okay, good job. So you've drawn arrows to show nucleophilic attack, and then what's going to happen after that? All right, good, good. The condensation. And what's the product called? Alpha beta up here, yeah? Alpha beta unsaturated carbonyl. There you go. So I think next week you're going to do something called the Claisen reaction. Do you know what that is? Okay, well, you'll learn about that, and then if you want to, we can go over that as well. But just trying to think about anything else. Do we know why? Do we know about, like, let's say we have this. So this is methyl cyclohexanone, I think that you would call that. Do we know, like, why there's so obviously we have 3 hydrogens here and only 2 here. Do you know which would be more preferred to do, to, like, if we wanted to enolize this? Okay, so you're saying this hydrogen because it's next to the methyl group. You would be correct, so well done. I'm trying to think what else I did when I was in your year. Yeah, I'm a postgrad student, so I'm just doing this in my spare time. Well, I mean, this is you're my first student, my first tutor student, so I would say it's going well so far, wouldn't you? Okay, so yeah, aldol condensation, and then you've got alkylation. Yeah, you knew about that. All right. Do you have any other questions? Oh, did I really like your perfume? Well, I mean, yeah, it was just a little bit of a surprise, that's all. I'm sorry if, like, I'm your tutor, I'm not meant to, you know, I'm sorry if I've made you uncomfortable. It's just, I mean, it's a really nice smelling perfume. I bet it was quite expensive. um, well, I mean, I'm glad you decided to go with that one. Hmm. Whichever perfume you decide to wear whenever we meet up, we can just use that molecule or that ester in our sessions. How about that? All right. I wonder which one you're going to have on next. um, okay. So, do you have any questions regarding the chemistry we've just gone through? No? Okay. Would you say this helped? I mean, obviously, I'm kind of new to this as well, but yeah. All right. So, next week, I think, yeah, you're going to go over the Clayson reaction and like intramolecular reactions. So, like a molecule reacting with itself. So that it kind of forms like a ring. I think you call it cyclization. Cyclization. So you've got that to look forward to. Um, so yeah, all right. I think that's it now. What is the time? Yeah, I've got a lecture to go to. So, do you have anything, or are you done for the day? Okay. Um, I've got a lecture to go to, so I will see you on Thursday. I think our next session is scheduled for. Yeah. All right. Um, okay then. You can keep this sheet if you want, just to look over it. All right. So I will see you in a couple days. All right. Okay. Bye bye.